Here is our review lesson on trigonometry for right triangles. The first thing that you need to remember when you're working with triangles, you want to label your vertices with uppercase letters and use that uppercase letter for the side length across from it. So for example, if I have triangle, we'll call this triangle A, B, and C, my side across from angle B would be lowercase b, my side across from angle C would be lowercase c, and my side across from angle A is lowercase a. Those are conventions that we always use for labeling triangles. The second thing you should know about triangles is that the angles in the triangle have to add up to 180. So if I want to find an unknown angle in the first triangle, I could take 180 degrees and subtract the 90-degree angle that's in the bottom corner and subtract the 23-degree angle that's in the other corner. And when we do that, we get 67 degrees. I just don't want to make a mistake, so I'm double checking with the calculator. Likewise for my other triangle, it's true for right triangles, but it's also true for this obtuse angle triangle. If I want to find that angle there, I could take my 180 degrees, subtract the 115 degrees, and subtract the 20 degrees. That's in the bottom corner there. And when we do that, we get 45 degrees for the top corner. Okay, so that's something else we need to know with trigonometry. The third thing you should remember is the Pythagorean theorem, and again, only works this time for right angle triangles. In this case, for the first example, I'm looking to solve for this hypotenuse. And remember, the hypotenuse is your longest side. It's the side across from the 90-degree angle. And when we're working with the Pythagorean theorem, the side by itself is your hypotenuse. So over here, this one's the hypotenuse. So we should have x squared is equal to 15 squared plus 20 squared. That's going to equal 225 plus 400. And that's going to equal 625. And the square root of, 15, that should be 25 as a square root. I'm just double checking my work. I need a square on that. Oops. And we got 25. So our x will equal the square root of 625, and x is equal to 25 centimeters. Now in part B, the hypotenuse was given as 12 meters. So this time when we fill in our c squared, it's 12 squared is equal to 10.2, 10.2 squared, plus x squared. So x is one of our shorter sides, and I'm just going to see if I can tidy that up a little bit. So that should be 10.2. So 12 squared should be 144. I have a 10.2 squared, 10.2 squared. I get 104.04 plus x squared. I'm going to subtract the 104.04 from both sides, and we get a 39.96 being equal to x squared. And then we're going to square root both sides, and we get x being approximately equal to 6.3 meters. Okay, for our short side. Moving on, if we look at something else we should know, this should have been a number 4 here, by the way. The fourth thing we should remember is the SOHCAHTOA. So that's where the sine is the opposite over hypotenuse. So O and the H, and then the cos, A and H, and then our tan, ooh, ah, look at the tan. Okay, so these are important things to know. Again, when we're working with our side lengths, we still have our corners with our capital letters, our side lengths are with our lowercase letters. But to help us do this, I also recommend for people or students to label their sides with hypotenuse and opposite. And the opposite goes with the angle that is given or that we're trying to find. It's never going to be the 90-degree angle. The hypotenuse is always across from the 90-degree angle. So on this example, across from the 15 degrees is 12 centimeters, so that 12 centimeters is the opposite side, and the third side then would be our adjacent side. Now, when I want to solve this one, if I'm solving for x, x is my hypotenuse, And I was given the 12, so 12 is the opposite. If I look at my trig ratio that uses opposite and hypotenuse, I'm looking at using the sine of the angle. So sine of our angle equals opposite over hypotenuse. So that came from up here. Okay. If I fill in what I know, I have the sine of 15 degrees being equal to 12 over x. Now x is on the bottom, so we have trouble solving when it's on the bottom. So I'm going to multiply both sides by x. And then that leaves me with the sine, x times the sine of 15 degrees being equal to 12. And then to get x by itself, I'm going to divide both sides by the sine of 15 degrees. And unfortunately, it doesn't look like that wants to do it. Let's see if I can squeeze that in a little bit higher up here. So we're going to divide by the sine of 15 degrees on both sides. And make sure your calculator is in degree mode while we're working with these. There are other units of measure for angles, but for now we're going to stay in degree mode. So I punched that into my calculator. Depending on how your calculator works, will depend on the order you punch things in. I get x is approximately equal to 46.4 centimeters. Now another known fact that we have from before is our longest side should be always across from our biggest angle, which our biggest angle is 90 degrees in this triangle, and we've got a 46.4 centimeters. Our smallest angle will be the 15 degrees, and we only have a 12 centimeters across from the 15 degrees. The other angle should be a 75 degree angle, and its side will be somewhere between 12 and 46.4 centimeters in length. Okay, so that's how we can solve for a missing side length. If we have two side lengths given and I want to find an angle, like this angle up here, I'll call that one theta. Again, I'm going to start with labeling my sides with hypotenuse. That's the top angle is the one I want to find. The side across from it then is my opposite, and that makes this third side the adjacent. Now I was given the opposite and the adjacent, so if I look at my trig ratios, the one that uses opposite and adjacent is the tan. So I want to use the tan, the tan of theta is going to equal opposite over adjacent. Filling in what I know, I don't know the theta, I will solve for the theta. Opposite was 5.8 and adjacent was 8.2. That's going to work out to be a decimal number. To solve for the theta, that's when I want to use that second function tan on the answer I get when I do that division. So you're either going to need to use brackets around the 5.8 divided by the 8.2 with the inverse function of tan, or you can calculate that first. So for on my calculator, I'm actually going to type in 5.8 divided by 8.2 and get that answer, and then I use my second function tan. And that gives me my angle theta being approximately 35 degrees to the nearest degree. It's 35.3 degrees if I go to one decimal place. So hopefully that helps you remember how to use SOHCAHTOA, and your job now is to practice some questions on that.